We use chi-square application when we're dealing with qualitative data, and we sort them into categories. When we have more than 2 categories, we'll use a chi-square application. So in this example, as a business owner, we are trying to determine which sauces you should order for your wings. Now, you believe there are no preference among the public for your wings flavors, but you wish to confirm this. One weekend, you saw 250 orders of wings and collected data. Construct a chi-square test at the 0.05 significance level. So this is where we would use a chi-square because we have an expected frequency. Now this is just the owner's preference, but this would be what we would call qualitative data. There's no true hard information to back up the claim. But now here we have our frequency observed of what we've actually seen happen. So this is a bit of quantitative, and what we can do is we're going to test whether this is just luck and this would eventually average out, or if we can expect to see a difference in customer preference. So to do that, we need to use our chi-square application formula. Actually, first we should set our hypothesis. So our null hypothesis is there is no difference between our frequency observed and our frequency expected. Our alternative hypothesis is there is a difference between our frequency observed and our frequency expected. So first thing we're going to do is determine our critical value of when we would reject the null hypothesis. So in this scenario, our degrees of freedom is equal to k minus 1, k being the number of categories. The number of categories is 5. We have 5 different wings flavors. So our degree of freedom is 4. We've also set our significance level to 5%. So if we go to a chi-square table, if we look up between degree of freedom 4 and our significance level of 0.05, we would get our critical value, and unfortunately the table is not in front of me, but that will be in your formula sheet, of 9.488. So this tells us that if our result is greater than 9.488, we will reject the null hypothesis, and that there is a difference in the customer's preference of wings. If it's lower than 9.488, we will accept the null hypothesis, and there is no difference. So we're going to use our formula for the chi-square application. And we need to do some work within our chart to be able to complete it. So first we need to determine our frequency observed less our frequency expected. And then we will take this number and we will multiply it individually. And then we can take each one and divide it by our frequency expected. So 36 divided by 50. So, after we less our frequency observed from our frequency expected, square them and divide them by our frequency expected, and add them all up, because this is all for the individual observations categories, we would get a chi-squared value of 5.4. So this is lower than our critical value of 9.488. So we would accept the null hypothesis. Any difference that we've noticed in wings flavors preferences is likely the result of chance.